Hi all, my name is Sanjeev Kumar and I'm a solutions architect at Amazon Web Services. Today I'm going to demonstrate how we can leverage Amazon Q Developer in building a generative AI application with complete infrastructure as code which can be reused to deploy the same application anywhere with just one click. Before I demonstrate, let me talk about generative AI first. Generative AI has become a focus for businesses of all domains more than any other technological shift in the recent years due to its broad applicability and powerful results. By 2026, Gartner's research indicates that more than 80% of enterprises are expected to have used generative AI in one shape or another for their enterprise applications. This is in comparison to just 5% in 2023. In fact, we believe that this year, many AWS customers with a proof of concept will move into production and start generating value for their businesses. At Amazon Web Services, we are not only helping our customers to build and deploy large language models on AWS, but also we have developed purpose-built services like Amazon Q Developer, which actually helps to improve the productivity of developers, which eventually generates more business value for the organizations. Talking about Amazon Q Developer, it is most capable generative AI powered assistant for accelerating software development lifecycle. Amazon Q Developer helps developers and IT professionals in development, testing, upgrading to troubleshooting, performing security scans, bug fixes, optimizing AWS resources, and creating CI/CD pipelines. Having said that, let us see Amazon Q Developer in action now. Before we move to the demo, let us look at the architecture of the application which we are going to build. So, if you look at the complete architecture, we are pretty much using all the AWS managed services. The scenario which I've taken is image to image generation. So we'll be taking a input image from the user, which the user will be uploading in Amazon S3 bucket. Once the image will be uploaded, a step function will be called, and that step function will be responsible to perform different actions. The very first action it will take is it will detect all the entities from the original image, and it will use Amazon recognition to extract all the entity details from the image. Next step, it will be storing all the entity details into Amazon DynamoDB, which is a AWS managed database service. And at the last step, another lambda will be called, and this lambda will actually call Amazon Bedrock, which is a generative AI service for AWS. And Amazon Bedrock will actually use Amazon Titan image generator, which will take the input entity details and a natural language prompt. And based on that, it will generate a high quality output image, which will be pretty much similar to what the original image was. And this lambda will then store that image into Amazon S3. This is the complete workflow. Now the question is why I chose this particular use case. The reason behind that, the major objective of this particular demonstration is to showcase how we can build complex infrastructure as code for cloud native solutions very easily using Amazon Q Developer. So now, without wasting any further time, let us build. So now I'm in VS Code and I opened Amazon Q Developer console on the left side. Those who are new to VS Code or Amazon Q Developer, you have to use the marketplace to add the plugin of Amazon Q. You can search with Amazon Q and install it. Once installed, you have to activate the plugin, either the free version or the professional one. Once you install it and activate the plugin, you have to open the console, and based on the natural language prompts which you will give, it will try to generate the code. The better the prompt, it will be able to better plan and execute whatever steps you have mentioned into your natural language prompt. So to build the application which I just showcased, we have to provide a prompt. I have already created that prompt in natural language. Let us just copy that prompt and we'll be pasting that prompt here. So yeah, so this prompt, I'm asking it to create a CDK application in JavaScript, which will be using step function, and it will implement a image processing workflow. I also told it what infrastructure I need to create, like the VPC, S3 bucket, step functions, all the step function jobs, then the DynamoDB table, all the permissions, and finally the complete CDK infrastructure I need with the best practices. So let me just copy it and paste in VS Code Amazon Q Developer Console. I will be going into the developer agent first, so that will help me to build everything in one go. So once you paste it here, you just need to press enter and it will take a few seconds to few minutes to generate the code. So here we are, it took a couple of minutes for me to build the complete code, and you can see that I've created the complete project structure with all the CDK as well as the application code. Let us have a look at it. Okay, so you see it created a very beautiful README file which helps any new developer to understand what the application is all about. Then all the dependency test files, the cdk.json file which will be used to actually deploy the application, and the most important thing, the infrastructure as code, which will be the image processing stack. This is actually responsible for creating the complete infrastructure. We have to input the S3 bucket name because the bucket names are usually unique. So just to avoid any confusion, let me put a name which is unique. It will create that bucket in the region which is set in my local profile for AWS. Then after that, you can see there is a DynamoDB table where all the entity details will be stored. Then the three Lambda functions which will be detecting the entity, storing the details of the entity in DynamoDB, and finally generating a new image using the large language model and Amazon Bedrock. Then all the permissions, what permissions are given to what functions for accessing bucket, DynamoDB, or Amazon Bedrock, or Amazon Recognition. Now, here you see the step function and the workflow of the step function, like how it will progress. If it gets successful, what will be the next stage and all. If it fails, what will be the next stage, right? So all of that is generated as infrastructure as code, and we actually didn't write even a single line for this. It was all generated based on the natural language prompt which I have provided to Amazon Q Developer. And finally, you can see the rule based on once the file is put into S3 bucket, this rule will trigger the step function and the actual workflow will get started. Now let us bootstrap the current workspace first. So I have to go into the project and run CDK bootstrap. So if you have not bootstrapped, you have to do it one time. Then the main step will be CDK deploy. So with CDK deploy, it will actually try to deploy all these resources into AWS account based on what is configured on my environment currently on local. So you can see it has started building the image processing stack. So initially it will be zipping all the Lambda function code which is in the Lambda folder, and it will be pushing that to the actual Lambda functions which will be created based on the infrastructure as code. So it may take a few seconds to a couple of minutes depending on what resources you create. Uh, uh, Sometimes it's very faster because if you generate some very simple resources, it may not take that much amount of time. In our case, we are using a lot of services. So now it have created the complete list what it needs to create. I have said yes to deploy all the changes. It may take 1-2 minutes here to create the complete cloud formation change set, and then one by one it will deploy all the changes in the sequence it is required. So let us wait for it. You can see the resources are in process of creation, right from VPC to logs to security group, IAM role, all the fundamentals, and then the specific AWS services. Okay, now I think we are pretty much done. It can complete any second. Uh, Once it will get completed, we'll go to AWS console and go to the cloud formation to see what it actually have created. So looks like it is completed. Here I'm in the cloud formation console and you see image processing task update complete. So uh, all the resources are deployed here. Now I go to the state machine, which is step function. You see the step function is already created here. I just saw that it was ran first time successful. That means once it was deployed, it was ran and it got completed. This is the Lambda code for one of the Lambda function. Looks pretty much good to me. This is the main S3 bucket where we are going to upload a file. So let me select a file. Let me upload it. Once it will be uploaded, the step function will get triggered. And let us go to the step function to see how it is looking now. Okay, so it is taking few seconds. I think it should complete any time now. So yeah, it is succeeded now. If you click on this, you will be able to see what all steps it have taken. It ran all the three major steps, never failed, got completed. Now let us go to the S3 bucket, but let us move to the output folder now. And this is the final image which was generated. Let us see the final image. Okay, looks good. Let us open the original image. Okay, so you see what we took as input and what the output is, and this is how we just built end-to-end generative AI application using Amazon Q Developer with complete infrastructure as code, and it hardly took much time for me. You may require one or two iterations sometimes because sometimes the which gets generated may not have one or two configuration enabled, or you might need to tweak it little bit, which actually I had to do just once, but that was very minimal amount of time it took for me, and ultimately you can see the end-to-end application running. I hope today's session was useful, specifically for developers who are looking forward to build generative AI applications. Thank you.